All right, welcome back. This is the next set of notes. Today is Wednesday, October 2nd. The screen in front of you is the slide that we took yesterday, where we just got an introduction to convergent boundaries. And today we're going to go through the first type of convergent boundary, the continental to oceanic collision. So make sure you have your document open. Plate tectonics class notes 6H. If you need to pause the video to go open it up, do that now. Once the document's open, come back so that you can take notes and you can listen to the information as I'm talking about a continental to oceanic boundary. Continental to oceanic plate boundary. So again, this is a convergent boundary, which means they are colliding into each other. But because there's two different types of crust, continental and oceanic, different things happen when these plates collide. So let's first start with a continental to oceanic plate boundary. So take a look at the picture first. Let me point out a couple of things that you should see. First thing that I want you to pay attention to is that you have your thin continental crust here. I'm sorry, your thin oceanic crust here, and your thicker continental crust here. And they are coming towards each other, but when they come into each other and they collide, the oceanic crust is then getting pulled back down towards the mantle. The next thing I want you to notice are two of the landforms that are being created. The first one is in the water itself. It's called an ocean trench. So it's like a big fall off in terms of where the ocean floor is. It gets really deep in these trenches. And then on the land, what looks like mountains. Okay? But the reason that these aren't just any old mountains is because of what's happening here. What's happening here, when this plate's getting pulled underneath, it's allowing some of this melted material to escape and come up through the continental crust. So these are actually volcanoes. We'll call them volcanic mountains. So you have volcanic mountains, you have trenches, you have the oceanic crust being pulled back down to the mantle. So what's going on? Well, the term is subducted or subduction for the ocean plate being pulled underneath the continental plate. And here comes density again. We're seeing it over and over and over in our first couple units. We remember from the layers of the earth and when we learned about the crust that one of the characteristics about the oceanic plate is that the ocean crust is more dense. Even though it's thinner, it's more dense than the continental crust. And so because it's more dense, it's the one when they collide, it gets pulled underneath. So we call this subduction, and the area that it happens we usually call a subduction zone. And subduction is just a geologic process in which one edge of one of the crustal plates is forced below the other edge. It's always going to be ocean crust. Ocean crust is always the one that's going to be subducted. Okay? If you're already thinking about the other convergent boundaries and you're curious about what might happen or you already have some questions about it, be patient. Over the next couple days as we get to the other ones, I'll explain what's happening and why. But hopefully you're already thinking ahead. That would be good. Like I said, what's happening in the subduction zone is that because the old ocean crust is more dense, it gets pulled back into the mantle and it gets remelted. So sometimes scientists even kind of call this the process of recycling the crust, because it's going to be remelted and then it could possibly be reused again for new seafloor at a divergent boundary. When there's seafloor spreading. This is also the reason why the planet's not getting bigger. If you're making new crust at a divergent boundary, there must be a place where crust is being taken away. And this is where that happens. In a subduction zone, it gets pulled back in and remelted. So what's the cause? What's the effect? Those are the causes. What are the effects? So at a continental to oceanic plate boundary, you can have the deep ocean trench, which would be with the ocean plate. On land with the continental plate, you would have volcanic mountains. The reason they're volcanic is because of the subduction, and when it's melting that plate, pressure lets some of this melted material fight its way up through the continental crust. And then because you have plates colliding, you can have earthquakes. Excuse me. Okay. That's continental oceanic plate boundary, one of the three types of convergent boundaries. Once you're done with your notes and the rest of your group, they're done with their notes, go ahead and meet each other, get your geologic or your plate boundary map out, and go back to that document and pick up where you left off. Goal is to get that map done by the end of the week, so you got to be working on that. Okay, new video will be out tomorrow. Work hard, and I will talk to you then. Bye.